Welcome everyone to this webinar hosted by Aventor, delivered by VWR and presented by CPS Nano.
On the market there are 4 instrumentation types. So to the top left here we got the conventional scanning spectrophotometer. That's very similar to the Beckman DU spectrophotometer and the model I'm standing with in front of me here. First you have the broadband light source, you have the monochromator, you got the sample with the cuvette, and you got the detector. Then as a bit of a later development we have the diode array spectrophotometer. Here you have a broadband light source, and then the light actually passes more or less directly through the sample inside the cuvette. Then follows a polarchromator, so basically an intern split and the dispersion device is placed after the cuvette. And then the polychromator then creates this rainbow of light. And then this rainbow is then directed towards a pixel array CCD, and from this diode array we can then have one color of the wavelength of the spectrum hitting one pixel, and thereby we know the value of this at this particular wavelength. This of course has the advantage that you can record an entire spectrum in parallel. It's very fast. However, your performance on the wavelengths, your accuracy is of course lower than the conventional scanning spectrophotometer. So both systems comes with some cons and pros. As further developments of the conventional scanning spectrophotometer, we have the scanning dual beam spectrophotometer, where after the monochromator the light is split using a chopper into both sample and reference, and thereby we can take better care of this background absorption A0 constant that I mentioned earlier, and the light is basically just converted to the same detector. Finally, we have the scanning split beam spectrophotometer, which is it's kind of the same configuration as the dual beam, but at the end we have 2 detectors, one for the sample, one for the reference. It's a slightly more expensive setup, but it does have its advantages as well.